Now we are going to start 28th problem. What they did, they want to check your vector knowledge with work power energy knowledge. They are saying body constrained to move in y direction is subjected to a force given by this. Work done by this force in moving the body through a distance of 10 j meter along y-axis. Means force is in vector form. Minus 2i cap plus 15j cap plus 6k cap. Displacement is again 10j cap. No I and k, so you can write it to avoid the negative marking. 0i, 10j plus 0k. Now, you will not do any mistake in calculation. You know that work is F dot D. It means minus 2i cap plus 15j cap plus 6k cap dot 0i cap plus 10j cap plus 0k cap. You know how to dot multiply? I coefficient with I coefficient 0. J with J, 15 into 10, 150. K with K, 0. So what we are getting? 150 joule. So very easily we got A option. Next, a body moves a distance of 10 meter along a straight line under the action of a 5 Newton force. If the work done is 25 joule, then angle between the force and direction of motion of the body is. Clearly they want to check your vector knowledge along with work power energy. We know that work done, actual formula in vector is F dot D. F dot D means FD cos theta. W is given 25 joule, F is given 5 Newton, D is given 10 meter, only theta we have to calculate. So by putting the values, we got cos theta is equals to W upon FD. What is W? 25. What is F? 5. What is D? 10. 5 5s are, 5 2s are. Cosine of which angle is 1 by 2? Everyone knows, 60 degree. So what is the answer? Theta should be 60 degree. Or if they are given in radian, pi by 3 radian, because pi is 180 degree. A force acts on a 3 gram particle in such a way that the position of the particle as a function of time is given by x is equals to 3t minus 4t square plus t cube, where x is in meters and t is in seconds. The work done during the first 4 seconds is, it is problem from 1998. A force acts on a 3 gram particle in such a way that the position of the particle as a function of time is given by this. The work done during the first 4 seconds is, first I will solve in two ways. One is wrong, one is correct, so that you should avoid this type of calculation. See, x is given, I am going with v first. What is v? 3 minus 8t. V, we know that velocity means rate of change of displacement. So I am differentiating this function, 3t3 minus 8t plus 3t square, because we know that what is v? V is dv by dt, dx by dt. V is dx by dt. What is acceleration? dv by dt. Again differentiate this. So acceleration is minus 8 plus 6t. What we will do, since acceleration is not constant, it means force is not constant. So we have to take the help of work energy theorem. It means work done should be change in kinetic energy. What was initial velocity? What was initial velocity? We will go for that. At t is equals to 0, v was 3. At t is equals to 4, v was 3 minus 32 plus 3 square 9, 9th at 4, 16 3s are 48. So we are getting 19. So what is change in kinetic energy? Half m v square, 19 square is 361, and initially it was half m, 3 square is 9. Take 3 upon 2000 common. $361 minus 9. What we are getting? For 1000 we will use milli. So we will write 3 by 2 into 361 minus 10, 351, 352 millijoule. We are getting 2 ones are 2, we are getting 528 joule. So nearest answer is D, so we are going with D. What some students and some books they are doing at that time to calculate one answer from this, they were doing this. I am telling you their wrong approach. It was their wrong method. What they were doing, they were calculating force acceleration at t is equals to 4. It is at t is equals to 4, they were calculating acceleration, means minus 8 plus 24, it is 16. and they are calculating force. Mass into acceleration, 3 upon 1000 into 16, 48 upon 1000. They are calculating x at t is equals to 4. They are getting x is equals to 3 into 4 minus 4 into 16 plus 64, 12. So they are saying work is equals to FD. Force was 48. Millijoule. 12 8s are 96, 9. 12 4s are 48 and 9, 57. So they are saying this millijoule is correct, 576. It is wrong approach. Why wrong? Force is not constant. Throughout the process, A was changing, force was variable. So you cannot do this. It is a wrong approach. So in that year, correct option was not there, but nearest answer was 530 millijoule. Take care of this. To get correct answer, you should not deviate from your concepts. Next, a force F acting on an object varies with distance x. The force is in Newton, x is in meter. The work done by the force in moving the object from x is equals to 0 to x is equals to 6 meter is. I told you that if force is variable, either we have to take the help of graph or the help of integration. Graph is there, so calculate the area bounded between your graph and displacement axis. Clearly your figure is trapezium, so work done means area of trapezium and it is half sum of parallel side. Length of this side is 6 and this side is 3. All are in SI units, so no tension. Distance between parallel sides, it is 3. So what we are getting? 6 plus 3, 9, 9 into 3, 27, 27 by 2 means 13.5 joule. So we are getting B option. We are getting B option. Next, a body of mass 3 kg is under a constant force which causes a displacement S in meters in it, given by the relation S is equals to T square by 3, where T is in seconds. Work done by the force in 2 seconds is. First we will check what is about acceleration, force is constant or not. Again we are taking the help of first differentiation. What is V? Rate of change of displacement. 1 by 3 is constant. T square, it is 2t. What is about acceleration? It is 2 by 3. Means force is constant. So in this problem, you can take help of that force into displacement. Particle is moving with constant acceleration. So now you can take help of that. What is force? M into A. It is 2 Newton. What is displacement? In 2 seconds, displacement is 4 by 3. 4 by 3. So work done is equals to force into displacement. We will get 8 by 3. In any way you will get same answer because force is constant. If you want to calculate work energy theorem, you can do work is equals to change in kinetic energy. What is change in kinetic energy? We have to calculate velocity at t is equals to 0. V was 0. At t is equals to 2, velocity was 4 by 3. So work done means change in kinetic energy at t is equals to 0, half m v square 16 by 9 minus 0. Initially it was 0, velocity was 0. 2 8s are 3 3s are. What we are getting? 8 by 3 joule. So you will get same answer. Why in previous problem different answers were there? Because force was not constant. 33rd. 300 joule of work is done in sliding a 2 kg block up in inclined plane of height 10 meter. Work done against friction is G is given. C. What is given? You done 300 joule of work to take this block from this position to this position. You did 300 joule. Where is your work gone? You spent 300 joule of energy. It should be stored in that box. But box got a height of 10 meter. We want to calculate change in its potential energy. What potential energy it got? mgh. mgh. So increase in its potential energy is just 200 joule. You spent 300 joule, but box got only 200 joule. Where is that 100 joule? It is wasted against the friction. So therefore, you can say work done against friction is 300 joule minus 200 joule is equals to 100 joule. So we are going with B option. 34th. Two masses of 1 gram and 9 gram are moving with equal kinetic energies. The ratio of the magnitudes of their respective linear momenta is. First I am giving you one formula which will help you in other problems also. What is the relation between momentum and kinetic energy? We know that kinetic energy, I am denoting it by K. It has a formula half m v square. Multiply and divide by m. M into v is momentum. p square by 2m. So we are getting p square is equals to 2km. So what is the formula for momentum and kinetic energy? You can write 2km. So remember this, if kinetic energy is k and mass of particle is m, its momentum should be root 2km. What they are saying in this problem, two different particles are there, but they have equal kinetic energy. The ratio of the magnitude of their momentum should be, if we want to calculate a ratio of momentum of two particles, we are writing in one root only, both are in root. It is for first particle, it is for second particle. 2 will cancel out with 2. They are saying kinetic energies are same, so we can cancel these. So what we are getting now, if we are putting same unit for m1 and m2, no need for conversion. Numerator again it is in gram, denominator it is again in gram. Gram is cancelled with gram. So what we are getting, 1 by 3 means 1 is to 3. The magnitude, ratio of magnitude of their respective linear momenta is 1 is to 3. So we are going with C. Next, the kinetic energy acquired by mass m and traveling a distance d starting from rest under the action of a constant force is directly proportional to constant force is applied. What kinetic energy it will get? We are going with work energy theorem. Work energy theorem. What kinetic energy is acquired by the particle starting from rest? Half mv square. Under the constant force, it should be equal to, force is constant, so we can apply this formula, force into displacement. So it is kinetic energy. Force is constant. The kinetic energy acquired by a mass m in a traveling distance d starting from rest under the action of a constant force is, so acceleration was constant. What is acceleration? It is F upon m. Starting from rest, u is 0. So what kinetic energy it will acquire? V we can calculate. V is equals to u plus at. Yeah, v square is equals to u square plus 2as multiplying both sides by m by 2. Same we are getting that work energy theorem. Since force is constant, so it doesn't depend on mass. Mass is not there, mass is not varying, force is constant, acceleration is constant, so m should be constant. So we are going with option B. No role of mass now. If you will calculate kinetic energy, m will be cancelled out. Multiply by half m. Multiply by half m. M will cancel out. So not dependent on m. 36th. Two bodies of mass m and 4m are moving with equal kinetic energies. The ratio of their linear momenta is 3 times they ask. One just we saw in previous, numbers were same, but in these 3 years, number was also same. So you can imagine how important this problem is. I told you in derivation in previous problem, then you can write momenta is equals to root of 2 kinetic energy into mass. For two different particles, the ratio should be, I am writing in same root, both are in square root, so I am putting only one root. For first particle 2k1 m1, for second particle 2k2 m2. Cancel 2 with 2. Kinetic energies, they are saying same, cancel these. So what we are getting? Root m1 upon m2. No need to convert units, but units are not given. M1 is m and m2 is 4m. Cancel m with m. What you are getting? 1 by 2. So we are going with option A. Two springs A and B having spring constant K and KB. Ka is equals to 2kb are stressed by applying force of equal magnitude. If energy stored in spring A is Ea, then energy stored in B will be, I told you for spring, two springs A and B having spring constant Ka and Kb are stressed by applying force of equal magnitudes. We know that what is force constant? It is F divided by X. F1, X1. For Kb, or we can write Fa, Xa, extension in first spring. For second, Kb is equals to Fb by Xb. What they are saying? Ka is equals to 2kb. It means Fa by Xa is equals to 2 times Fb by Xb. But they are saying forces are equal. So we can cancel Fb with Fa, since they are saying Fa and Fb are equal. So this implies extension in B spring is equal to double the extension in A spring. We want to calculate energy stored in B first in terms of energy stored in A. So first we will write what is energy stored in A. Ea means energy stored in A. It should be half K X square. So I know Ea in terms of Ka and Xa. So I will calculate Kb in terms of Eb, Ka and Xa. Then only I can guess what multiple of Ea, Eb is. It should be half Kb Xb square. What they are saying about Kb? They are saying Kb is Ka by 2. So I am writing it Ka by 2. What about Xb? They are saying it is 2Xa. So what I am getting? Half Ka by 2. 4 xa square. Cancel this 4 with this 4. But to compare, I need 1 by 2. So I am multiplying and divide by half. Half Ka xa square. To cancel this 2, I am multiplying by this 2. What is this half Ka xa square? It is Ea. So I am getting 2 Ea. So I will go with option A, 2 Ea. 38th problem. A particle is projected making an angle of 45 degree with horizontal, having kinetic energy K. 2 times they ask this. The kinetic energy at highest point will be. We know that when particle started from this point, its velocity was 40 u. Suppose its velocity was u. So its kinetic energy was initially half m u square, but they are saying it is k. When it reached at this point, the vertical component of velocity is vanishes. It was u cos 40, u sin 45. Due to gravity, it becomes 0. Horizontal component is constant everywhere. So at this point, particle has only horizontal component u cos 45, means u by root 2. So its kinetic energy at highest point, it should be, mass is same, half m. U square, what is it? U by root 2. So u square, root 2 square means 2. So what we are getting? K by 2. So we are going with option B. So in this way, B option was correct. A child is sitting on a swing. Its minimum and maximum heights from the ground are 0.7 meter and 2 meter respectively. Its maximum speed will be. We know that its height from the ground, it is a swing. Height from ground, it is 0.75 meter. Suppose the mass of this swing with child is m. So at this point, its initial potential energy was mgh. M G H. If he is swinging, and at this point its velocity was v. So kinetic energy at this point, okay, we will discuss from this only. We will take this as 0. At this point, if the velocity of swing was v, so its energy was half m v square, maximum at this point. When swing is getting height, this velocity, this kinetic energy is converting into potential energy. So at maximum height, it will become 0. whole kinetic energy is converted into potential energy. But according to our formula, potential energy, gain in potential energy should be mg into gain in height. What gain in height is there? From 0.57 meter, it is now at 2 meter. Means gain in height is 1.25 meter. So mgh, h is 1.25 meter. Cancel m with m. G is 10. So V square is 10 into 1.25 into 2, 2.50 means 25. Means velocity maximum value is 5 meter per second. So what we are getting? 5 meter per second. Next, when a long spring is stretched by 2 centimeter, its potential energy is U. If the spring is stretched by 10 centimeter, the potential energy stored in it will be, again same formula related to spring. We know that energy stored in a spring, it should be half kx square. It is the formula for energy stored in a spring. They are saying when we stretch the spring by 2 centimeter, energy stored is U. Suppose CGS value of spring constant is K and I am taking energy in CGS unit only. So half K, 2 square means 4. So 4 by 2, U is 2K. Now I stretch the spring by 10 centimeter. So new energy, spring is same, K is same. Half K x square. So new energy is 100 by 2, 50 K. What is K? K is U by 2. Means 50 into U by 2. So new energy should be 25 U. What we are getting? 25 U. New energy is 25 U. Next, 41. Force is given in vector form. Velocity is given in vector form. We want to calculate instantaneous power. I told you what is the formula for power. F is equals to, power is equals to F dot V. What is the power's formula? F dot V. Means 60 I cap plus 15 J cap minus 3 K cap dot 2 I cap minus 4 J cap plus 5 K cap. So F dot V, I coefficients, multiply coefficient of Y with coefficient of I plus coefficient of J with coefficient of J plus coefficient of K with coefficient of K. So what we are getting? 120 minus 60 minus 15. 120 minus 60, 60, 60 minus 15, 45 watt. So we are going with B. 42nd. In theory, I told you the coefficient of restitution E for a perfectly elastic collision is 1. So we are going with 1. What is coefficient of restitution? Ratio of velocity of separation upon velocity of approach. 43rd, a moving body of mass m and velocity 3 km per hour collides with a rest body of mass 2 kg and sticks to it. Now the combined mass starts to move. What will be the combined velocity? Since they sticks, it means it is an example of inelastic collision. Only linear momentum will conserve. So initial linear momentum. I am putting mass in, mass is given in term of m and 2k. Initial linear momentum, mass m, velocity 3, so 3m. Second was in rest, so its momentum was 0, so total initial momentum was 3m. After that, they stick together. Total mass is 2m plus m, 3m. Velocity suppose v. So by law of conservation of momentum, by law of conservation of momentum, 3m is equals to 3mv. Cancel 3m with 3m, we are getting 1 km per hour. So we are going with C. 44th, a metal ball of mass 2 kg moving with a speed 36 km per hour. Head-on collision with a stationary ball of mass 3 kg. Both balls move as a single mass. Loss in kinetic energy due to collision is. Again, only law of conservation is there. So initial linear momentum (2 kg) into 36 km per hour multiplied by 5 by 18 to convert in meter per second. Second ball was stationary. So total momentum was 10 into 2, 20 kg meter per second. Final linear momentum. Suppose velocity is v. So 3 kg and 2 kg, 5 kg, and velocity is v. So by law of conservation of momentum, (5v) is equals to 20, so v is equals to 4 meter per second. So loss in kinetic energy means initial kinetic energy minus final kinetic energy. Initial half, one was at rest, so no kinetic energy with that, and it was half m. V was 36 into 5 by 18 square. It was initial kinetic energy minus, what is final? Half. Total mass is 5 kg and speed is 4 this joule. What we are getting? 18 2s are 36, 2 5s are 10, 10 square 100, cancel 2 with 2. So we are getting 100 minus 4 square is 16, 16 by 2 8, 8 into 5 40. So we are getting 60 joules. So we are going with D. two equal masses m1 and m2 moving along the same straight line with velocity +3 and -5 collide elastically. Their velocity after the collision will be, masses were equal, so there is only change of velocity. First particle's velocity was 3. Now second particle's velocity should be +3. Only in this. Second has -5, so first should have -5. So we are going with D. So in this way, we completed our second unit. In next slides, we will start third unit. Thank you.